All right, guys. This is chapter 10, part 2, day 2. Your homework is page 261, numbers 10 through 16. There's going to be like a part H, like there will be somewhere that asks for a part H. Don't worry about part H if that comes across. Okay, just skip it, but do the other parts for sure. Yeah. Cool. All right. Sorry. What was I saying? You don't need questions and reflections anymore. Or table content. Don't worry about that anymore. We're only doing one notebook check. I do want you guys to take notes just because you guys are probably gonna have a quiz on chapter 9 and 10. Most likely probably either the end of this week or next week. Yeah. This week or the beginning of next week, some sort of quiz. Okay, and then I'm still trying to think about a project or a test that we can do. But yeah, all right, let's move on. Yeah, you don't need question reflections, just have the notes and the homework. I would still organize it the same way. Yeah, I would still organize it the same way that we've been doing. Okay, just because it makes sense. All right. So the first thing that we want to talk about is this thing called sample versus experiment. We kind of talked about it. Sampling experiments use randomization. You guys could take a pause and put all this down. Sampling estimates population parameters, like something about the whole population by getting a sample that's representative of the population. Talked a lot about that. Experiments try to assess the effects of a treatment. So we're doing something. In an experiment, we're trying to do something. In a sample, we're kind of asking them, seeing what's going on. A baseline measure is called a control treatment. A control group is the experimental units assigned to a base level treatment or a placebo treatment. The responses provide a basis for comparison. So a control group is kind of just a group that you're not doing anything to. You're giving them what's called a placebo, just so that they think that they're doing something, but it has no effect. Example, I want to see a black light will help bamboo grow taller. The treatment experimental, so the treatment group will be the one that has the black light, and the control group will be the plants in normal sunlight, because normal sunlight is what they normally get anyways. That's the control group. I'm not changing anything there. Let's say I'm testing medicine, right? Right? The treatment would be what? Treatment would be the new medicine. The control would be a placebo. And a placebo is just like a pill or something. That's essentially, it's a sugar pill, right? It doesn't really affect them at all, but you give it to them just so that they don't know, oh, do I have the placebo or do I have the treatment? You still give them something so that they know that that nothing, that they're not biased in some sort of way. Okay. Blinding. Any individual associated with an experiment who is not aware of how subjects have been allocated to treatment groups is said to be blinded. Blinding is important. You do not want people to know what group they're in because it can affect, like if I'm giving you guys, just with the medicine group, right? With medicine, I'm not going to tell them, hey, I'm going to give you guys Tylenol. And like this group, hey, I'm going to give you guys a placebo. I'm not going to tell them what they're getting because the people that know that they get Tylenol might trick themselves into thinking that, they might trick themselves into thinking, this Tylenol is working because I'm taking it. My headaches have gone down. No, we don't want to tell them anything. We want them to come to these conclusions naturally instead of telling them a specific medicine. So you don't want to tell your subject tell the subject what they're taking. Single blind versus double blind. There are two main classes. So those who could, so a single blind is applying to the subjects, like the subjects don't know. A double blind is both the subject and administrator. Okay, so in a double blind, right, not only the subjects don't know, but the administrators don't know. The reason why a double blind is really important is because if I work for a if I work for, let's say, the cigarette company, right, and half the people smoke cigarettes, half the people, I don't, stupid example. Let's say I work for a medicine company and I want to show that my medicine works, right? If I know the people that are doing my medicine, then of course I'm gonna probably push the stats to show that it's more effective. If I know who's doing what, I might lean one way or another depending on, depending on my situation. But by doing a double blind, I don't know who's taking what. I'm just recording data. That's all I'm doing. I'm just recording the results. I don't have any biases because I don't know who's taking what. That's called a double blind. In an experiment to see if the new pet food is now safe, we're feeding one group of dogs the new food and another group of food that we know to be safe. Our response variable is the health of the animals. How should the vet be blinded? So the vet shouldn't be told which animal's doing which food, right? The vet should not be told which animal has each food, because if the vet knows that this has the new food, then the vet might rig the data in some sort of way for it. Okay, how would you do this? I would just bring in pets and not tell the vet. Bring an outside party, bring a third person, bring like a third vet in, or something like that. Like bring a vet that's not associated with the company, and just have them test the dogs without telling them anything about the experiment. Just blindly test them. All right. Can this experiment be double blinded? Yeah, I guess like the vet can be blinded, and then like us as researchers can be blinded as well. Like we don't need to know which dog has which food, right? You can't blind the dog in this because the dog would know the difference between the foods, right? Like the dog wouldn't know. But you can blind the vet who's actually doing the tests, and then you can blind the administrators, the people who are giving out the dog food, so you don't tell which was which. A placebo, a treatment known to have no side effect, administered so that all groups have the same condition. So like I said, if you're doing like Tylenol, you want to give them a placebo just because you want to make sure that everybody's taking something, whether it's effective or not effective. Okay. All right, let's move on. Placebo effect. The tendency of many human subjects, often 20% or more, to show response even. Like the placebo effect. You guys hopefully have heard of it. It's essentially the idea that although you have a placebo, you don't know it's a placebo, so you think it's working. Like, oh, you're taking a Tylenol. Oh, my headache's gone. Well, no, it's a sugar pill, right? Right? It shouldn't really do anything, but your mind tricks yourself into thinking that it is doing something, essentially. That's the idea of a placebo effect. Okay, let's move on. So these are the best things for experiment. You want to do randomized. Comparative. Comparative means that you're able to compare two groups, like, or multiple groups. You're able to compare a lot of groups. Double blind and a placebo controlled. Blocking. When there are pre-existing differences among the groups of experimental units, it is often a good idea to gather them together into blocks. By blocking, we isolate. So essentially, blocking is stratifying your groups. You're putting everything into one. So example, like by common property, you're stratifying into one. Example: 12 plants from store A. It's 6 plants from store B. So I'm blocking. Right? I'm blocking. I have a block. I'm putting all my plants from store A into one group. All my plants from store B into one group. And then from there, I'm breaking it up into smaller groups. Okay, that's what blocking is. Okay, that is. Blocking, once again, is you're just taking the plants, like this initial one, everywhere, and then you're separating into groups that they have a similar characteristic. Like, I don't know, if I'm doing an experiment on the class, right, a blocking that I could use is all the males versus females, and I could run experiments like that. Do the male experiment separately, the female experiment, because what that does is it allows me to really focus on that one variable, that one property of like, oh, males have this property, or females do this better, and so on and so forth. Okay. Randomized block design. In a randomized block design, the subjects are randomly assigned to treatment only within blocks. So you're blocking randomly, not by a property, you're just blocking randomly. In a retrospective or prospective study on an experiment, subjects who are similar in ways not studied may be matched and compared with each other on the variable of interest. Matching, like blocking, reduces unwanted. Okay, so matching. Matching is actually really cool. It's kind of the idea of pairing something up and then comparing the two. If I want to do a study on whether band kids perform higher in school, I might want to match a band student with a non-band student, right? So the property, right? The property that I'm doing is band. If you're in band, I'm going to partner up you with a non-band. But what I'm going to make sure is that the gender is the same and the family income is the same. The reason why I want to make sure that the gender is the same and the family income, I want to make sure that gender and family income don't play a part. The only thing that differentiates them is the band versus non-band member, and I compare their data. By matching, we'll eliminate gender and family income as a source of variation. Confounding when the sorry, I just dropped something. When the levels of one factor are associated with the levels of another in such a way that, God, my spelling is horrible on this slide, that their effects cannot be separated, we say that these two factors are confounded. Blinding helps reduce confounding. So, for example, a professor teaching exactly the same course in the spring and fall with the same material and the same test. In the fall, he is more monotone and laid back. In the spring, he is more energetic and excited. Students in the fall rated his teaching lower than students in the spring. Okay, why? Well, in the fall, he was more monotone and laid back. But in the spring, he was more energetic and excited. So he was kind of like a more like entertaining teacher in the spring. So that's why. That's what's confounding. When the levels of one factor are associated with the levels of another factor in such a way that their effects cannot be separated, we say that the factors are confounded. So what's confounded in this is the season, right? Is the season. Everything is the same. Spring, everything is the same. Material and tests are the same. Sure, students are different, but we're assuming that the students are similar. Like all the students that come to this class are similar. The only thing that's different is the season change in his mood in this season. That's confounded. That's the level, right? That's the factor that's associated with this change. It's the season, right? It's the reason why there's a change. If everything is the same, there's a reason why they're two different, and that's confounding. Okay. So confounding is kind of similar to a lurking variable. A lurking variable is the thing that ties two unrelated things together. Example, more shark attacks versus higher ice cream sales, right? The reason why is because more ice cream sales is usually summer, which leads to, God, my spelling is horrible. Summer, which leads to the beach. And if more people go to the beach, there's more shark attacks. Confounding is when one factor seems like it leads to result, but it's actually caused by something else. Okay, so here's a picture of a lurking variable. A lurking variable, you have two things, x and y. X and y are tied together between this one thing. So in my example of a lurking variable, x would be ice cream sales. Y would be shark attacks. Shark attack and ice cream sales are linked together, but what's the thing that links them together? It's the beaches. More people go to the beach, right? Or let's say summer, right? That's the lurking variable there. Summer. People eat more ice cream in the summer. Sharks. I don't know. People go to the beach more in the summer. So, sharks. So it matches together. What confounding is, it's one thing that leads to another, but it's actually caused by something else. So let's see a picture of that. Right. So X leads to Y, right? But confounding leads to Y as well. So Y is created by two results: is confounding, but it's caused by something else. Okay. So in our example, right, lower rating of professor, right? What we thought the confounder is the season, right? Right? We talked about the season being like the main influence. No, but the reason why he got a lower teacher rating was because he was more energetic versus laid back. Energetic and laid back doesn't necessarily have something to do with the season, right? So the X and confounder don't really tie together. But we had said that the confounder, it was the season, right? That we thought naturally, oh, the season's the only thing that's different, so that's the confounder. No, it's the fact that in those seasons, he was energetic or laid back. And I can have those moods switch. Like in the fall, he can be more energetic. In the spring, he can be more laid back. Like the season doesn't matter. We think it matters, but it's not the thing that matters. The thing that matters is that he was energetic versus laid back. That's why he got lower teaching rating. All right, guys, that's pretty much all I got for this. Like I said, I would just keep you your notebook up to date. Please read that little paragraph that I wrote if you guys haven't already. It took me some time to write that out, so read it. Maybe you'll find some value in it. But besides that, get ready for a quiz either on Friday or next week. We'll probably do a we'll probably do a Zoom meeting probably on Thursday to talk about any questions that you guys may have. Cool? All right, yes. Have a good one.